What's up, everybody? My name's Trey. Welcome back to the TS Steelworks channel. Today we're going to be doing a machining project. I was asked to modify a Torx bit to fit into a cordless impact. So I was given the material, and we're going to start here on Fusion 360 and do a little design work to try and get some numbers to plug into the computer on the CNC milling machine. On this channel here, we do machining, blacksmithing, all kinds of projects. I'd love for you to subscribe and stick around till the end to see how this one turns out. So here is the bit that I was supplied, and they want it to fit into a cordless impact. So we'll have to actually start by cutting the excess material off, probably just with a right angle grinder, and then we will chuck it up in the lathe, turn down the body, and put in the little indent where the ball detent goes in the drill. And then we'll chuck it up in the milling machine in a 5C cullet and cut the hex on it, on the shank, so that it'll fit in the impact driver. So let me show you here what I came up with on Fusion 360. So here's the bit. As you can see, we got some material to remove. So let's head out into the grinding room first and get the 4-inch grinder and cut these billets down to something workable. Alright, we're over here at the super sloppy workbench, and the customer asked for it to be around this long. This was the example I was given. Just a standard Phillips bit that goes in a impact driver. So we're just gonna mark all these. The overall length isn't super critical, so just give her the old eyeball. Alright, let's go cut them. Alright, we're out here in the grinding room, as you can see. So we're going to turn our exhaust fan on. But before I do that, I'm just going to chuck this up in this big old honking vise. And yeah, go at it with the 4-inch grinder. little bit hot. Not too bad. Not too good. Alright, the machine we're going to start on, which is slightly destroyed by my garage, is a Alpha 400 semi CNC lathe. I say semi because you can set stops and things. You can send programs to it, but it's not a full CNC. So let's get this fired up first. All right. So we're going to be using a, see if we can see this, 1/4-inch round tool, or like round groover. And I'm just going to cut the OD with it and that little notch in there at the same time, with the same tool rather. There's our little blank. This material is crazy hard. Something's moving. Get that out of the way. Looks like I need to hold on to about this much. Got this tool number 7. Let's just do a little manual cutting. Too fast. Alright, I had a stop in here, 1.225, 0.285 diameter. I like that. We're gonna speed this feed up to 8. Let's make sure we can go back 1.225. Well, it didn't hit. Alright, that's it for that step. That's pretty painful, but we made it. It's just really hard material. I don't know what it's made out of, but they're meant to be tough, and they did a good job. They're tough, so we'll do the other 4 to that stage there, and then we'll head over to the milling machine and mill the hex on it. So stay tuned. Alright, now that we've got the body turned down to the correct diameter, we have to put the groove in for the detent. So this little groove right here. So this material is a little too hard to even center drill, so I'm going to use a cone live center. That's what I'm calling it. I'm not sure what the actual name is, but instead of the standard pointy live center, it's actually concave, I guess you would say. To be honest with you, it came in a kit for a live center, and I forgot I had it. And I'm glad that I have it because it is coming in clutch. So let me set you up, and we'll cut our detent groove. I did end up annealing the shank on this one. It seems to be cutting much better. Yeah, lesson learned. I wasn't sure if they wanted them to remain the same hardness though, but after talking to the customer, they said, yeah, just soften them up and it won't be a big deal. So super thankful that I did that, and it should make milling the hex on it quite a bit easier as well, which we like. So let's set another one up and do it again. Alright, so I'm actually using my tool as a stop. So I set it at Z plus 30 thousandths, and now I'll put my material in. Pull it out till it hits the tool. And now I know I need to face 30 thousandths off that. Alright, it's faced off to 0. So we'll load up our stop program and start cutting the OD. Okay, that's all 6 of them. So next we will set up the VF3 to cut the octagon on the end. So first I'm gonna have dinner, and then we'll set up the VF3. We're over here at the Haas VF3, so we'll fire it up. And we're going to use a 5C collet holder. And I have this collet that has a hex in it. So it's going to hold these tool bits. And then I will put that collet block in a 6-inch Kurt vise. And then we will write a program to cut our hex, and we're going to do it with a 1/2-inch carbide end mill. No particular reason, it's just an end mill I have a few of, so we'll use that, and we'll go from there. So let's get that set up, get a program wrote, and get milling. Very simple program here. We're just running a subroutine, so we'll use cutter comp. That way we can adjust the size as we need to, and just a simple little program. I got it wrote up here. We can watch it in graphics. That's it. Simple as that. Just took 20 years of experience to be able to do that. So let's set up to put a bit in the collet block. So again, here's our collet block, 5C collet block. Put that in there. Tighten this nut up on the back. There's probably a spanner wrench for this, but I don't have one. Uh-oh. I think my phase converter is getting ready to self-destruct. It is awful vocal. It's a terrible idea. Let's not work against ourselves here. Alright, that's in there. So let's put it in the machine now. Alright, so we're just going to simply put this on a parallel. Give that a little tighten. Then we're going to take our edge finder and find the center of this. It doesn't look very centered. I'm not happy with that. We're going to put an indicator on the side of this and see if that thing's sitting in there straight. Yeah, I didn't think so. So let's straighten it out. So now we're going to actually edge find the part, not the block. She is moving. I don't understand. it's definitely moving in the collar. It must only be pinching like at the top or something. I think that's better. Unfortunately, now we got to reset everything, but I think this is the only way to really hold this thing. So let's indicate the side again. Let's refine our X0. I'm happy with the Y0. It's going to be fine. X is going to be different every time. So as that other bit is running, let's do a little bit of deburring on the 2x72 belt grinder. Nice chamfer on the end. This one here actually tried to come out of the chuck on me on the lathe, but we saved it. Multicolor, because I annealed the shaft on this one after. So. Well, folks, that's it. That's going to end the video. All 6 are done. So just for a summary of the project, we took T60 Torx bits that measured about 5.5 inches long. We cut them with a grinder and then turned them in the lathe and then put them in the milling machine and milled the hex on them. These are going to a company by the name of Diligent Defense. They build suppressors. They reached out to me and asked me to modify these bits for them, and it's been a really fun project. A little more challenging than I expected, to be honest, and I think that was just due to the hardness of the material, but we got through it. They will have 6 custom bits that I've never seen on the market. I'm sure you could get something like this, but this is what they wanted, so this is what they get. I really appreciate everybody watching. If you could subscribe, that would be great. That really helps the channel out. I'm trying to build a channel here with machining and blacksmithing, metal fabricating, all the cool things that I get myself into in my home shop. And I appreciate watching. We'll catch you on the next one.